So this is the first chemistry class of 2021. I'll be teaching you, as I told you in the biology class, I'll be teaching you biology as well as chemistry in class 8. So the first chapter, for those who do not have the book, I would like to say, I would like to inform you about some of the chapters in class 8 in chemistry. The first chapter is matter. The second one we have already done in class 7, physical and chemical change. Then again, the same chapter would be repeated here also. Elements, compounds and mixture, that we've already done last year. Atomic structure, language of chemistry, chemical reactions, and the new one would be chemical reactions, hydrogen, water, carbon and its compounds. So the first 4 chapters we have already done earlier in class 7. It is just a repetition in a little bit higher standard, that's all. So it's almost the same. Chapter number 1, 2, 3 and 4, matter, physical and chemical change, elements, compounds and mixture, and atomic structure. So the first chapter I want to discuss today is matter. And in this matter, the key concepts that we will study about are main postulates of kinetic theory of matter, change of state of matter on the basis of intermolecular force of attraction, or the intermolecular space and the force of attraction, and the third one is the law of conservation of matter. So these are the key concepts that we will discuss in this chapter. So the first point I would like to discuss would be the definition of matter. As we all know, matter is anything that has mass and occupy space. Is it okay? We have already done that in class 7. Matter is made up of tiny particles called atoms or molecules. Usually, an atom does not exist independently. Therefore, some combine to form molecules. So, what is matter? Matter is a pure substance made up of small particles called atoms and molecules, and has mass and occupy space. So that's all about matter. So anything that has mass and occupies space is called matter. Now when we talk about matter, we obviously have to deal with the kinetic molecular theory of matter. Okay, so what is it? What is this theory all about? The theory that enables us to understand the behavior of molecules in the 3 states of matter, that is solid, liquid and gas, is called the kinetic theory of matter. So the theory that enables us to understand the behavior of the molecules in the 3 states of matter is called kinetic theory, or the kinetic molecular theory. So the postulates of kinetic molecular theory of matter are as follows. Number 1, composition of matter. Matter is composed of molecules, and the molecules of a given substance are identical in all respects. For example, molecule of water is made up of the formula of water, as we all know, it is H2O. So it is a molecule of water is made up of 2 atoms of hydrogen, H2O. H2O is water, so it is made up of 2 atoms of hydrogen and 1 atom of oxygen. Altogether 3 atoms makes one molecule of water. So 3 atoms means 2 atoms of hydrogen and 1 atom of oxygen make altogether 3 atoms combined to form 1 molecule of water. And all the molecules of water, anywhere you go, they are identical. They are exactly the same. Next is movement of molecules and kinetic energy. And now you know that molecules always gain energy. When you heat a substance, obviously the molecules will gain kinetic energy and they move randomly, whereas if you cool a substance or the temperature goes down, the molecules will have less kinetic energy and they cease to move. That means they do not move. So, the molecular movement of molecules and kinetic energy. Molecules in matter, they are never stagnant, they always move around. Due to this movement, molecule possesses kinetic energy. So actually, it is because of the kinetic energy that the molecules possesses, they are never stationary. So the kinetic energy of molecules in matter changes with the heat. If you heat a substance, the molecules will gain kinetic energy. If you cool a substance, the molecules lose kinetic energy. And obviously, if the molecules move randomly, they tend to have a lot of kinetic energy. They tend to move away from each other. That means the intermolecular space will increase. So if you cool a substance, the molecular force of attraction increases and the intermolecular space decreases. The molecules will come closer to each other when you cool the substance. So that is all about the movement of molecules and its kinetic energy. So intermolecular force of attraction. So there is always the force of attraction between the molecules. The molecules, like the planets, they attract each other, isn't it? The moon and the sun and the Earth, they are all, and the other planets, of course, they attract each other. Similarly, the molecules also, they have force of attraction. They attract each other. And this force of attraction is known as the intermolecular force of attraction. So the force of attraction between the molecules is called the intermolecular force of attraction, and the force of attraction becomes stronger as the molecules move closer to each other. The molecules, when they move closer to each other, the force of attraction is more, and if the molecules move away from each other, or if the kinetic energy of the molecules increases, the molecules goes further away from each other, and if the more the distance between the molecules, lesser will be the force of attraction. So closer the molecules, force of attraction is strong. Further away the molecules are, the force of attraction between them is less. So as the molecular space between the molecule decreases, the intermolecular force of attraction increases, and vice versa. So the force of attraction between the molecules of the same kind is called cohesive force. There are two types of force of attraction. Force of addition and the force of cohesion. So force of cohesion is the type of force of attraction between the same type of molecules. Okay? Same type of molecules. There is a force of attraction between them, and this is called cohesive force. Like water, if you put a little bit of water, you pour it on a table or a plate. Okay? What will happen? They do not, if the table or the plate is perfectly in a horizontal surface, if the surface is totally horizontal, then it forms a cluster of water. The pool of water is small, tiny pool of water which will not spread out or which will not flow. It remains there. Why? Because of the force of cohesion. Because of the force of cohesion, the force of attraction between the water molecules, the same type of molecules, which binds them together. Okay? So then the water will have, the force of cohesion of water would be more, so that they form a pool of water in a horizontal table or a horizontal, perfectly horizontal plate. Okay? So the attraction, the force of attraction between the same type of molecules is called force of cohesion. And what is the force of addition? Force of addition means the force of attraction between the molecules of different kinds. So different kinds of molecules also attract each other. So this kind of attraction between the different type of molecules is called adhesive force. It is known as adhesive force. So, for example, let's say mercury. So mercury is the only metal in a liquid state, isn't it? So the mercury, you put it in a dish, okay? You put it in a petri dish or a small dish, and then you see it moving. It sort of moves the whole molecule. They will not separate, like they do not flow like water. Okay, because the force of cohesion is more than the force of addition, isn't it? Like I said, the water little bit of water that if you pour it in a horizontal surface, it forms a small tiny pool of water and remains there. Why? Because the force of cohesion is more than the force of addition. But if you dip your hand in a bowl of water, your hands get wet. That means the molecules of water will stick to their skin. Isn't it? Your skin becomes wet. Why? Because of the force of addition or adhesive force. So the force of attraction between the molecules of different kinds is known as force of addition. So last one, the next one would be collision of molecules. Now, normally the molecules, they are never stationary, as I already told you. They always possess energy, little bit of energy. So when the molecules, they move around, they are bound to collide. They are bound to hit against each other, and this is known as collision of molecules. So molecules of a substance, they collide with each other. In the gaseous and a liquid state, the molecules also collide with the walls of the container in which the substance is kept. So molecules not only collide with each other, they also collide with the walls of the container. And the number of molecules that hit the surface or maybe the wall of the container, that will give you the pressure. That will give you the pressure of the liquid or the gas on the surface of the or maybe the wall of the container. So the number of molecules that hit the surface of the container determines the pressure, in other words. Okay, it determines the pressure. Next is the movement of molecules in different states. Now you know there are three states of matter. We have already studied that in the lower classes: the solid, the liquid, and the gases. The solid, liquid, and gas are the three states of matter. So the molecules of matter are always in motion. They are never stationary. In molecules, in the solid, the molecules, they vibrate in its mean position. They do not move around like in the case of solid, liquids and gases. The solid molecules, they move, but they vibrate in their mean position. Whereas in the case of liquids, they move around, all around. If you heat water and you put maybe a few tea leaves, then you will see as the water gets heated up, the more the temperature, the more random motion you will see. Okay, the more random motion that you will see in the molecules or in the tea leaves that you have put in. Few tea leaves that you have put in the hot water. So they move randomly. But the molecules, they move within the liquid. They do not move away from out of the liquid. Only when you heat it high, when it reaches its boiling point, then the the molecules of the water will leave the surface of the water, and then they turn into a gaseous state and move about freely. So gases, they move freely. Is it okay? So the molecules of matter are in motion. In solids, they only vibrate in their mean position. As the temperature of the substance increases, its molecules move faster, and thus the kinetic energy of the molecules increases. As I already told you, if you heat a substance, the kinetic energy of the molecules will increase, and therefore they move away from each other, and then they move in the random motion. In case of liquids, they move within the liquid, but if it's in a gaseous state, then they move wherever they want to. For example, when the water is boiled, the molecules move faster, and thus the kinetic energy increases. So kinetic energy of the molecules increases, therefore the motion of the molecules is random more vigorous in hot water. When water is cooled, the molecules move slower because the kinetic energy decreases. So if you cool the liquid or any state of matter, the kinetic energy also decreases, and the movement will become less. So in the next class, we are going to talk about the change of state of matter and why does it occur. The change of state of matter, why does it occur, and the law of conservation of mass. But for now, we will end this first class with the kinetic theory of matter, or the kinetic molecular theory of matter. So I hope you've understood today. If you have any problems, you can always contact me. Hope you enjoyed the class. Thank you so much.